Hello. In this video, I am going to explain transformations, and I'm also going to work with some angle pairs. So let's get started. So here is my point. It's 2, -5, 2 to the right, 5 down, from 0, 0. I'm going to reflect it across the x-axis. This is the x-axis. It is below the x-axis now. When it reflects, it will be above the x-axis. It is 5 below, so its reflection will be 5 above. 1, 2, 3, 4, 5. Put my dot right there. Then I want the coordinates. It goes 2, 5. Positive 2, positive 5. And that's how you reflect across the x-axis. Next, translate using the rule xy becomes x minus 3, y plus 7. This is the x-axis. It goes left and right. Plus minus 3 would mean left 3. So left 3. This is the y-axis. It goes up and down. Plus means up. So therefore this is up 7. Left 3, up 7. I'll start at this point. I go 1, 2, 3. And then I go 1, 2, 3, 4, 5, 6, 7. And that's where my point will be. It will be at -1, positive 2. And I'll just get rid of my intermediate points because I don't want to leave any artifacts. Okay so far? Next. Now I'm going to rotate 90 degrees clockwise. The first thing I'm going to do is draw, it goes 2 to the right and 5 down. Clockwise is this way. So I'm going to go this right becomes down, and this down becomes left. So this, I should change colors. This becomes this. And the point goes right there. Rotate 90 degrees clockwise. And those coordinates are -5 because it's 5 to the left, and -2 because it's 2 down. Notice the way that the x and the y trade places. Whenever you're rotating 90 degrees, the x and the y are going to trade places. Okay. Now I'm reflecting across the y-axis. Well, this is the y-axis, so let's reflect across it. We start out to the left, reflecting will end up to the right. It's 3 to the left, so we will go 3 to the right, and it ends up right there. There's 3, there's 3. So what are the coordinates? Well, it's 3 to the right and 1 down. 3, -1. All right, any questions so far? Make sure to ask your teacher. Let's move on. So now we're going counterclockwise. So let me change colors. 3 this way, 1 this way. Counterclockwise is this way. Counterclockwise. So this will go down to there. All right. So 3 this way becomes 3 this way. 1 this way becomes 1 this way. See how the L shape rotates like that? And that means our new point will be right here, and its coordinates will be 1, -3, because it's 1 to the right and 3 down. All right. X translate x plus 4, y minus 2. X is left and right, plus is to the right, plus 4 means right 4. Y is up and down, y means down, down 2 in this case. So I start at my point, I go right 4, 1, 2, 3, 4, and down 2, 1, 2, and I end up right there, and its coordinates will be 1, -3. And then I just want to erase all the part in the middle because we only want to see the result. Okay? All right, let's move on to angles. So find all the missing angles. Well, first, this is a right angle symbol. So a right angle is always 90 degrees. Hey, I did one. Let's move on. This is 43 degrees, and this is a straight angle. A straight angle is 180 degrees, so to get this one, I will do 180 minus 43, which is 137 degrees. To get this angle next, well, this is a straight angle, and that's 180 degrees. So to get the other part, I will do 180 minus 90, which is 90 degrees for there also. Next, do you see this triangle? We all know that a triangle adds up to 180 degrees. So we've got a 43 and we've got a 90, so we'll do 43 plus 90. That's 133. To get the last one, it has to add to 180 because it's a triangle. So we'll do 180 minus 133. And that answer is 47 degrees. I think I'm wrong. 80 minus that is, yep, 47 degrees is correct. Okay, next. Now that's 47, and this is vertical to it, so that's 47. And if those two are 47, then the corresponding pieces down here are also 47. To get this one here, this is a straight angle, so we'll do 180 minus 47, and that is 133 degrees, which we've seen before, and that's not a coincidence. And then, if that's 133 degrees, then this is 133 degrees. And if those two are 133 degrees, then the corresponding angles are also 133 degrees. And that's all the angles. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 angles that you could figure out based upon just one number. Just want to clean it up a little bit. Okay, let's move on. Which of these sequences of transformations would put a shape back to its original position and orientation? Circle all that are true. All right, so here's an x and a y-axis. I'll put a point down. I'm going to reflect it across the x-axis. It would go up here and then reflect across the x-axis again, and I end up down here. This one puts it back in its original position and orientation. All right, now I have a spot. I'm going to go 3 to the right. 1, 2, 3, and then 4 to the left, 1, 2, 3, 4, and then 1 to the right, and I end up back where I started. So that one brings it back. Next. Rotate 30 degrees clockwise, so I'll put my point up here. I'll go 30 degrees clockwise and then 40 degrees clockwise. So 30 plus 40, that would be 70 so far. And then 110 degrees, so that would be 180 degrees altogether. Because 30 plus 40 plus 110 equals 180. Is that bringing you all the way back? No, bringing you all the way back would be 360 degrees, and it doesn't go 360 degrees. So that one does not return it to its original position and orientation. Next. Here's a space, here's a dot. I'm going to put my dot. I'm going to go 4 spaces left. 1, 2, 3, 4. Then I'm going to go 4 more spaces left. 1, 2, 3, 4. Does that end up where it started? No, it ends up 8 spaces to the left. So that one does not return it to its original position or orientation. Okay, now I start up here. I go 90 degrees clockwise. I end up there. I go 90 degrees clockwise again. I end up there. 90, 90. I do a third one. 90, and I do a fourth one. Hey, 90 plus 90 plus 90 plus 90 plus 90, 4 of them, is equal to 360. And 360 returns you to where you started. So that one does return it to its original position and orientation. Next. So we want this to turn into this. So doesn't it have to turn to the right? Doesn't it have to rotate? So let's rotate 90 degrees clockwise. That turns a shape that's going up to a shape that's going to the right. Now, if I rotate this point 90 degrees clockwise, it ends up there because up becomes right, and that's how it ends up there. Is this point there? No. So we have to do one more step. I have to move it to there, which is to translate one space right. Let's see if that works with all the points. So this is 2 and 5. So I'll go 2 and 5, and I end up there, and then I move it one space right, and I end up there. So it worked over 2 points so far. Now this one is 4 and 1, so I'll go 4 and 1, and then move one space right, and I end up there. It works for all 3 corners, therefore it works for the whole shape. Next. So the 2 lines that I'm talking about being parallel are this one, and they certainly look parallel, but we can't go by looks alone, because I could put it by a slight bit off, and then somewhere way over in that direction they might connect. So let's prove that they are parallel. Well, we notice that this angle and this angle are congruent, right? And those 2 angles are corresponding. And remember, it's an if and only if situation. So if these 2 are congruent, if 2 corresponding angles are congruent, therefore those 2 lines must be parallel. So how do we know that they are parallel? Corresponding angles are congruent. If I wanted to write that using symbols, I would write corresponding. I don't have a symbol for corresponding. Angles are congruent. And that's writing it in symbols, but it means exactly the same thing. And that's everything. If you have any questions, contact your teacher.